So you'll get this final relation after the removal of self loop and transitivity. You will get this final relation. So set can be represented by roster method and set builder form. Roster form or set builder form. So here we have to use AND operation, logical multiplication. Take this column and this column. Now first find out this LHS value and next find out this RHS value. We have to prove that LHS is equal to RHS. Hello everyone, I am Shweta, Computer Science Faculty, Vidhyaashram First Grade College, Mysuru. So dear students, already have discussed all the concepts in your syllabus, right? So discrete transformation is very simple concept, but you have to practice the problems properly. So today I'll discuss one model question paper on discrete transformation and also I will discuss the question paper pattern. So please practice these important questions. This type of questions you can expect for your coming exams. So let's get started now. So discrete transformation is your 80 marks theory paper and 20 marks is your internal. So now, out of 80 marks, you have part A and part B. So in part A, you can score 20 marks, that is 2 marks, 10 questions. So you will get 12 questions. You will get 12 questions in part A. So you have to attend 10 questions. So each question carries 2 marks. So 2 into 10 is equal to 20 marks. So in part A, you can score 20 marks, that is 2 marks questions. So you have to attend 10 questions in part A. So 2 questions is choice. So easily you can score 20 marks in part A. And coming to the next part, that is part B. So in part B, we'll be having 4 questions. So each question carries 15 marks. So you can score 60 marks in part B and 20 marks in part A. So 60 marks. So each question carries 15 marks. So you have to attend 4 complete questions. So in every questions, you will get one choice. That is, example 13A, B is your first question. So again, you'll be having choice. Again 13A, B or C. Clear? So if question A carries 7 marks and question B is 8 marks. So 8 plus 7 is 15 marks. So this question carries 15 marks. So you can attend this question or also you can attend this question. So here 15 marks is partitioned into 7 marks or 4 marks question and 4 marks question. So like that, you'll get the division of 15 marks. Is it clear? So now you have to attend 4 questions in part B. So each question carries 15 marks, 15 marks. So you can attend the first question or the second question. Is it clear? So in every unit, in part B, in every unit, you'll get 2 questions. Example, so totally you have 4 units, unit 1, unit 2, unit 3 and unit 4. So in first unit, you will get 2 questions. So you can attend first question or second question. Again, in second unit, you will get 2 questions. You can attend the first question or second question. And again, same thing for unit 3 and for unit 4 also. In every unit, you will get 2 questions. You have to attend 1 question in each unit. So you have to prepare all the topics in every unit. Clear? So easily you can score 80 out of 80 marks in discrete transformation. It is very easiest subject in your syllabus. So this is your question paper pattern. It is 80 marks theory paper. So now I'll discuss the part A questions. So this is part A. So in part A, you have to attend 10 questions. Each question carries 2 marks. So first question, define roster method with an example. So in set theory, this is your set theory unit 1 concept, that is set theory concept. In set theory, you have 2 methods. So set can be represented by roster method and set builder form. Roster form or set builder form. So very important question. You can expect roster method or you can expect set builder form also. So what is this roster method in set? The set is represented by listing all the elements. Set is represented by listing all the elements. So what is the meaning of set? Set is a listing all the elements is called as roster method. Example. So here I have written one set elements. Set is represented by a capital letter. So A is equal to 1, 2, 3, 4. Is it clear? So now the elements are enclosed within braces and separated by commas. So elements are enclosed within a braces and commas. Clear? So now I'll give an example for roster method. So what is roster method? Set is represented by listing all the elements. Example, set of vowels in English alphabet. So a set of vowels in English alphabet. So this is called as set builder form. This is not a roster form. This is set builder form. We have to convert this into roster form. So set of vowels in English alphabet, that is A is equal to, caps A is equal to A-E-I-O-U. Is it clear? Set of vowels in English alphabet. This is a sentence called set builder form and we have to convert this into roster form, that is A is equal to A-E-I-O-U. So what is the definition? Set is represented by listing all the elements. Is it clear? And second example, set of odd numbers less than 10. Now this is a set builder form. I have to convert this into roster form. So set of odd numbers less than 10. So from 0 to 10, how many odd numbers are there? 1, 3, 5, 7, 9. These are the odd numbers in set of odd numbers less than 10. So here I am listing just the elements. Listing the elements is called as roster method. Is it clear? This is 2 marks question. You can give any other examples. So first you have to write the definition and one example. And the next question is, so here you have two set elements, set A and set B. So find A union B into A intersection B. So first you have to find this A union B and A intersection B, then relation. So now A union B. So what is A union B? So in set operations we have different types, that is union operation, intersection operation and difference operations and complement operation, etc. So now first I will find out A union B. So what is A union B? So here you have to merge all the elements of set A and set B and you are not supposed to repeat the same element. And here we have 1, 3, 5 and here 1, 2, 5. So merging of elements, that is A union B is 1, 2, 3, 5. And here 5 is repeated, 1 is repeated. You are not supposed to repeat the element, same element. So once you have to write this in union operation. And next is A intersection B. So what is A intersection? Which is a common for both set A and set B. So 1, 5, 1, 5 is a common for both set A and set B. So A intersection B is equal to 1, 5. And next is, so question is A union B into A intersection B. So first find out this A union B and A intersection B. And next is question A union B into A intersection B. So now first write down this 1, 2, 3, 5, that is A union B into A intersection B is 1, 5. Now relation 1 to 1 and 1 to 5, 2 to 1, 2 to 5, 3 to 1, 3 to 5, 5 to 1, 5 to 5. Clear? That is called multiplication, product. So 1 to 1 and 1 to 5, 2 to 1 and 2 to 5, 3 to 1 and 3 to 5, 5 to 1 and 5 to 5. This is your answer. So this is for 2 marks. So explain each and every step properly. So definitely you can score in discrete transformation. Please explain the steps properly. So A union B, A intersection B, and the question is A union B into A intersection B. This is product. So here we got the answer. This is your final answer. Is it clear? And the next question is, draw the graph for the relation R equals 1, 1, 1, 3, 2, 1, 2, 3, 2, 4, 3, 1, 3, 2, 4, 1 on the set 1, 2, 3, 4. So here I have 4 vertex 1, 2, 3 and 4. Is it clear? So now 1 is connected to 1 means what? It is a self loop. 1 to 1 is a self loop. This is self loop. Graph, here we have to draw a graph for the given relation. So here we have one relation and set elements 1, 2, 3, 4. So how many sets are there? 1, 2, 3 and 4. So for this we have to write the graph for a given relation. So 1 is connected to 1 and 1 to 3. 1 to 3 and 2 to 1. 2 to 1. So 1 to 1 is self loop and 1 is connected to 3 and 2 is connected to 1 and 2 is connected to 3 and 2 is connected to 4 also and 3 to 1. 3 to 1 and 3 to 2 and 4 to 1. That's it. I'll repeat. 1 to 1 is self loop. Self loop. 1 to 3. 1 to 3 and 2 to 1. 2 to 1 and again 2 to 3 and again 2 to 4 and again 3 to 1. 3 to 1 and 3 to 2 and 4 to 1. So this is your graph. So here mention the direction, so easily you can draw a graph. By using this relation r is equal to 1, 1, 1, 3, 2, 1, 2, 3, etc. So we can easily draw a graph. This is for 2 marks. And next question is define preposition, give an example. So what is this preposition? Preposition is a collection of declarative statement. Preposition means it's a statement. Either the statement is true or it can be a false. So preposition is a collection of declarative statement that has either a truth value is true or a truth value false. So statement can be a true or statement can be a false. That is called as a preposition. Example, A is less than 2. A is less than 2. It is because unless we give a specific value of A, we cannot say whether the statement is true or false. Is it clear? So here we don't know the value of A. Simply they have given one statement, A is less than 2. So whether it can be a true or it can be a false, until we know the value of A, we can't predict the statement is true or false. Clear? And you can give any other example. So milk is in white color. Is the statement is true? Yes, it is a true statement. Clear? So like that you can give a statement true statement or false statement. That is called as preposition. And next is find the negation of the preposition. Vandana's smartphone has at least 32 GB of memory. So negation of the prepositions. So in preposition you have some logical connectives, right? So here find the negation of. So what is negation? It is just an opposite of the given statement. Vandana's smartphone has at least 32 GB of memory. So what is the negation of this? So negation can be represented by this symbol or also you can use this negation symbol. Is it right? So Vandana's smartphone has at least 32 GB of memory. So what is the answer? Vandana's smartphone does not have at least 32 GB of memory. So this is called as negation of this given statement. Clear? So negation means Vandana's smartphone has at least 32 GB of memory. And what is the negation? Vandana's smartphone does not have at least 32 GB of memory. This is for 2 marks. And the next question is question number 6. For all positive real numbers x and y, if the product xy exceeds 25, the x greater than 5 or y greater than 5, transform the statements using quantifiers. So this problem is in mathematical logic. So here we have a statement that if the product XY exceeds 25, that means, so you have to write the steps for all, the symbol is for all X and Y belongs to R plus, that is all positive real numbers, for all positive real numbers X and Y. Clear? For all, this is a symbol of for all positive real numbers X and Y, and if the product, so if the product XY exceeds 25, if XY is greater than 25, if XY exceeds 25, then means you can use this simplification, right? So implies X greater than 5 or Y greater than 5. So transform the statement using quantifiers. So this statement you can write it in a quantifier form. So if XY is greater than 25, then X is greater than 5 or Y is greater than 5. This is called as the quantifier statement. So I'll repeat this. For all positive real numbers. So for all positive real numbers can be represented by the symbol for all positive real numbers, that is X and Y. If the product XY exceeds 25, the product XY exceeds 25, then X is greater than 5 or Y is greater than 5. So this statement you have to transform this into quantifier. So what is the statement? So if P, then Q. Already I have explained this, right? If P, then Q. So you can use this concept. If XY is greater than 25, then X is greater than 5 or Y is greater than 5. So if XY, then X is greater than 5 or Y is greater than 5. So this is called as mathematical logic, that is the concept of quantifiers. And the next one is, what is a sequence? Give an example. So a sequence is an ordered list of numbers. So what is the meaning of sequence? So sequence means is a list of numbers. So example 1 plus 2 plus 3 plus 4 up to n numbers. So this is called as sequence. Sequence is an ordered list of numbers. Clear? So here I have written 1, 3, 5, 7, 9, odd numbers less than 10. So the series is 1, 3, 5, 7, 9. So it is 2 marks question. And the next one is, what is a well-ordering principle? So this concept is mathematical induction. So in mathematical induction, you can expect this question, well-ordering principle. So well-ordering principle states that every non-empty subset of Z plus contains smallest element. That set of all positive integers is well-ordered. Example, in mathematical induction, you are finding the set of all positive integer is a true statement, right? So S of n is true, K is true and K plus 1 is true. So here finding the set of all positive integer is a well-ordered, is it right? So example 1 plus 2 plus 3 plus n is equal to n into n plus 1 by 2. So you can take this example. So here set of all positive integer is well ordered. That is called as a well ordering principle. So in well ordering principle, every non-empty subset of real numbers contains a smallest element. Clear? This is for 2 marks. And the next one is define permutation and combination. Very, very important question. So what is the definition of permutation and combination? Permutation. Permutation relates that act of arranging all the members of a set into some sequence of order. So in permutation, we are arranging the set of elements, some sequence of order, right? We are arranging the elements. So arrangement is matters in permutation. Arrangement is matters in permutation, and the combination is a way of selecting items from a collection of such that, unlike permutations. So here We are arranging the set of some sequence of order, set of elements in some sequence of order. We are arranging in a permutation. So arrangement matters in a permutation. And in combination, combination is a way of selecting items from the given permutation. So arrangement does not matters in combination, but arrangement matters in permutation. Clear? So the order of selection does not matter in combination. So this is a difference between permutation and combination. And you can write the definition, and also you can write NPR formula and NCR formula if it is comparison for permutation and combination. And the next one is define cut vertex and cut edge. Very important question. So cut vertex. So what is graph? Graph means is a collection of vertices and edges. Is it right? So graph is a collection of vertices. Example 1, 2, 3, 4 and 5. So here graph means is a collection of vertices and edges are called as a graph. So now cut vertex and cut edge. Removing a cut vertex from a graph breaks it into two or more graphs. So removing a vertex. Example, I'll remove this vertex 2 and vertex 5. I'll remove this vertex 2 and 5 and the remaining one is, so it is 4. I remove this 5 vertex 5 and vertex 2 also. So here removing a cut vertex from a graph breaks it into 2 or more graphs. Is it right? So here I have removed this 5 and 2 vertex. So it breaks it into another form of graph. Is it clear? So this is called as cut vertex. So you can give any other example for cut vertex. And cut edge. If removing an edge in a graph results it in 2 or more graphs, then the edge is called a cut edge. So here I'll remove this edge 1, 2, 3, 4 and 5. So totally we have 5 vertex. So here I'll not remove the vertex, I'll remove the edge. Now I'll remove this 1 to 2 and remaining edges. So here I'll remove this 1 to 2 edge and 5 to 4. So this is an example for cut edge. So this is for cut vertex and this is cut edge. So removing an edge is called as cut edge. Removing the vertex is called as cut vertex. Clear? So you can give any other examples also. So next one is what is digraph? Digraph is also called as directed graph. What is this digraph? A directed graph is a graph in which the edges are directed by arrows. The edges are directed by arrows. Example 1 to 2. Edges are directed by arrows and 1 to 3 and 3 to 2. So it is an example for digraph or directed graph. So here a graph in which edges are directed by arrows. Clear? So edges are directed by arrows means it's a digraph or directed graph. So I'll write one more graph here. Is this digraph? No, it's not a digraph because edges are not directed by arrows. It is undirected graph. This is directed graph. And the last question in part A is write any two applications of trees. So what is this tree? Tree means it's a acyclic graph. It does not contain any cycle. So it does not contain any cycle means it's a acyclic graph. Clear? So what are the applications of trees? So tree means is a hierarchical structure, right? So it stores hierarchical data like folder structure, organization structure. Clear? So I have explained all the basic concepts of trees in my previous concept classes. Please watch all the sessions. So here this is 2 marks question. Write any two applications of trees, that is we are using in a hierarchical data like folder structure and organization structure. So this is about your part A So in part A, you will get 12 questions. You have to attend only 10 questions. So each question carries 2 marks. Easily you can score 20 marks in part A. And the next question is part B. It is 13A. So verified distributive law. So you have to practice all the laws. Definitely there will be a problem on this concept. Distributive law, commutative law, associative law, idempotence law, etc. So now your question is verified distributive law. So set A is equal to 1, 2, 3, 4, 5. You have 3 set elements A, B and C. So you have to verify this distributive law. So what is a distributive law? So first write the distributive law properly. A union B intersection C is equal to A union B intersection A union C. And now first find out this LHS value and next find out this RHS value. We have to prove that LHS is equal to RHS. So first I'll take this B and C elements, which is a common element for both set B and set C. So 6 is a common. So B intersection C is equal to 6. And next is A union B intersection C. So you have to use this union operation for this B intersection C and for this set A. So now union means merging of elements. So 1, 2, 3, 4, 5 and here you have 6. So what is the answer? 1, 2, 3, 4, 5. 6 is the answer for this A union B intersection C. Clear? This is your LHS. Next find out RHS. So first I'll find out this A union B. What is A union B here? So A union B is merging of elements 0, 1, 2, 3, 4, 5, 6 is the A union B. And find out this A union C. So A union C is A and C. So 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6 is A union C. So now again the RHS, complete RHS is A union B intersection A union C. So you just take these two values A union B intersection. Here you have to use intersection for this A union B and A union C. So which is a common for both set A union B and A union C. So 1, 2, 3, 4, 5, 6. Here you have 0. Here 1, 2, 3, 4, 5, 6. So common is 1, 2, 3, 4, 5, 6 is common in both A union B and A union C. So I'll write 1, 2, 3, 4, 5, 6 is a RHS. Now this is your RHS value. Compare with LHS. So here you have 1, 2, 3, 4, 5, 6. Here also you have 1, 2, 3, 4, 5, 6. So LHS is equal to RHS. Both the values are equal. So we have verified this distributive law. So please practice this laws of logic. You have associative law, distributive law and commutative law, etc. So definitely there will be a problem on this concept, verify distributive law or verify associative law, etc. So you have to find out this. You have to prove that LHS is equal to RHS. And the next question is question number B, 13th B. If f is a function from R to R with f of x is equal to x square minus 4. The given f of x is equal to x square minus 4. Find f inverse 12 and f inverse 5. Is it clear? So now this is our given question. F of x is equal to x square minus 4. So you have to prove that f inverse, clear? F inverse 12, f inverse 5. So how to find out this f inverse 12 and f inverse 5 for a given function f of x is equal to x square minus 4. So now consider y is equal to f of f inverse x. Clear? So consider y is equal to f inverse x. This is equation number 1. And now what is f of y? Just cross multiply this. If y is equal to f inverse x, consider y is equal to f inverse x. And what is f of y? F of y is equal to x. Is it clear? Now, if f of x is equal to x square minus 4, And what about this f of y? F of x is equal to x square minus 4. F of y is equal to y square minus 4. Understand the logic? So consider y is equal to f inverse x. So now I am taking this y is equal to f inverse x. So just cross multiply this f of y is equal to x. If you are shifting this to that side, so inverse will be cancelling. So y is equal to f inverse x, f of y is equal to x. If f of x is equal to x square minus 4, and what is f of y? F of y means y square minus 4 is equal to x. Now find out the value of y. So y square is equal to x, cross multiply this 4. So y is equal to square root of x plus 4. Now we got the value of y. I'll substitute here. Y is equal to square root of x plus 4. So now I'll find out. Now we got the value of y. Y is equal to square root of x plus 4. This is my equation number 2. Now I'll use this equation. So y is equal to f inverse x and y is equal to root of x plus 4. So now I'll find out this f inverse 12. So now what is the value of x here? X is equal to 12. So substitute the value of x here. F inverse 12 is equal to, x value is 12 plus 4 is equal to root 16 is equal to 4. So F inverse 12 is equal to 4. So like that, F inverse 5. So square root of x plus 4. So what is the value of x here? X is equal to 5. So 5 plus 4 is equal to root 9. This is 3. So this is your answer. So very important question. Please practice this so you can expect any other different questions on this topic. So that is function. So F inverse and F inverse. So you can use this method. So first consider this y is equal to F inverse x. So now you just interchange the value of x to y, y to x and substitute the value of F inverse 12, F inverse 5. You will get the answer. And the next question is C. If f and g are two functions, so here we have two functions, that is f and g, by f of x is equal to 2x plus 5 and g of x is equal to x square plus 1. So now we have to find g of f and f of g. So I have discussed so many problems, right? So now first I will find out g of f. So you can also written as g of f of x. G of f can also written as g of f of x. Clear? Now, so f of x means what? It is g of x, that is 2x plus 5. In place of f of x, I have written 2x plus 5. Now, in place of x, in place of g of x, I have 2x plus 5. You just substitute the value of x here, you will get the answer. So, g of x means g of 2x plus 5 is equal to x means 2x plus 5, 2x plus 5 whole square plus 1. Clear? And now, this is in a form of a plus b whole square. So, a square plus b square plus 2ab plus 1, that is 4x square plus 20x plus 26 is g of 2x plus 5. This is called as g of f. I'll repeat. So, g of f you can also written as g of f of x. Now, f of x means what? It is 2x plus 5. Now, this is in a form of g of x. Is it right? So, what is g of x? G of x is equal to x square plus 1. Replace the value of x here. So, in place of x, you can put this 2x plus 5. Now, g of 2x plus 5 is equal to 2x plus 5 whole square plus 1. You just expand this, you will get the value. So, next is f of g. F of g means you can also written as f of g of x. Now this is in a form of f of x. Is it right? So now what is g of x? G of x is equal to x square plus 1. Now this is in a form of f of x. So I'll substitute the value of f of x. F of x is equal to what? 2x plus 5. Now f of x square plus 1 is equal to 2 into x means x square plus 1 plus 5. So 2x square plus 2 plus 5, it is 2x square plus 7 is the answer. Clear? This is f of g and this is g of f. Definitely there will be a problem on this f of g and g of f concept. Clear? So this is your first 13th question, 13th A, B, C, and next is again you have one choice or 13th A. So show that A intersection B union C is equal to A intersection B union A intersection C. So already I have discussed this distributive law, associative law, right? So this is regarding the laws of logic in set theory. So you have to prove that LHS is equal to RHS. So already I have discussed this distributive law, right? So take one example for this, set A and set B element and set C element. Clear? So take any other set elements for this and now you have to prove that LHS value equals RHS value. So already I have showed this, right? So you can take any examples for set A, set B and set B. Prove this LHS value is equal to RHS value. So this is for 5 marks. And the next one is let f be the function from A, B, C, D and 1, 2, 3, 4. So here A, B, C, D and 1, 2, 3, 4 with f of A 4, f of B 2, f of C is equal to 1 and f of D is 3. So is f is a bijection. So here we have to prove that is this function is a bijection or not. So first you have to understand the logic of bijection. So what is bijection? Bijective means a function which has both injective and surjective function are called as bijective function. That is one-to-one function and on-to function are called as bijective function. So here they have given the function f is a, b, c, d and 1, 2, 3, 4. So here they have given domain and codomain. I'll write the domain a, b, c, d and codomain is 1, 2, 3, 4. So here, so what is bijective function? Every element of codomain has an image in domain. Every element of codomain. This is domain and this is codomain. Every element of codomain has an image of domain. That means, so they have given that f of a is equal to 4. So f of a means, so here I have domain. F of a has an image of codomain that is 4. A to 4. And f of b is 2. F of b is 2. F of c is 1 and f of d is 3. So every domain has an image of codomain that is one-to-one and on-to function are called as bijective function. So here every domain has an image of codomain. So it is a bijective function since it is a bijective function. It is a bijective function. Clear? This is called as bijective function. And the next question is, let A equals 1, 2, 3, 4, 5, 6, 12, 6, 8 and 12 and R be the partial ordering on A defined by A or B. And if A divides B, so this is very important. If A divides B, find R. So here draw the Hasse diagram of the poset partial order set A and R and determine the relational matrix of R. So now how to draw a Hasse diagram? So first you have to list the element, given element set A is equal to 1, 2, 3, 4, 6, 8 and 12. So now you have to write the relation for this R be the partial ordering on defined A or B if A divides B. So here they have given the set of elements. So A divides B. Find R. R means you have to find the relation for this A divides B. So first I'll write the relation for this. So 1 can divide 1 and 1 can divide 2, 1 can divide 3. 1 can divide 4, 1 to 6, 1 to 8 and 1 to 10. So first list all the divides elements. So here they have mentioned A divides B. So you can assume this is A and this is B. So 1 can divide 1 and the next element 1 to 2, 1 to 3, 1 to 4, 1 to 6, 1 to 8 and 1 to 12. Is it clear? And 2 divides 4, 6, 8, 12. 2 divides 2 and 4, 2 to 6, 2 divides 8, 2 can divide 12 also. And next is 3. 3 divides 8, 3 to 3 and 3 to 6 and 3 to 12. And next is 4. 4 to 4 and 4 to 8 and 4 to 12. Clear? And next is 6. 6 divides 6 and 6 can divide 12. Next 8. 8 divides 8 and 12 divides 12. So this is a relation. First you have to write the complete relation, that is A divides B. Clear? So this is a relation. Have written the relation. So for this I have to write the Hasse diagram. So now we have some rules for this Hasse diagram. So you have to remove the self loop. Remove self loop and transitive property. Transitive property you have to remove, and you have to remove the self loop. So remove the self loop means you can remove this self loop. Clear? And self loop. And next is transitivity. So what is this transitivity? So 1 to 2, 2 to 6 and 1 to 6. 1 to 2, 2 to 6. That is A to B, B to C, then A to C. Is it right? So A to B is 1 to 2, B to C is 2 to 6, and what is A to C? 1 to 6 is A to C. So you can remove this 1 to 6. Is it clear? So you just remove that. So you will get the relation. So like that you have to remove the self loop and transitivity. So you just mention this step also, remove self loop and remove transitivity. For writing the Hasse diagram, you have to follow this step, remove self loop and remove transitivity. You just check all the transitivity and next you can write the complete relation. So finally I'll get this relation, that is 1, 2, 1, 3, 1, 4 and 1 to 6. So 1 to 6 already have removed this. So after this removal of self loop and transitivity, you will get another relation, that is 1 to 2 and 1 to 3. And next is 2 to 4 and you will get 2 to 6 and 2 to 8 and 3 to 6 and 4 to 8. So you will get this final relation. After the removal of self loop and transitivity, you will get this final relation. For this relation, you have to write the Hasse diagram and relational matrix. So how to write the Hasse diagram for this? So 1 is connected to, I'll write it here, 1 is connected to 2 and 1 to 3. 1 can divide 2 and 1 can divide 3 and 2 can divide 4. I'll write 4 here. 2 can divide 4 and 2 can divide 6. So 2 to 6 and 3 to 6 also we have 3 to 6 and 2 to 6 also. and 2 to 8. So for this relation, you have to write the Hasse diagram and relational matrix. So I'll write it here. So 1 divides 2 and 1 divides 3 and 2 to 4 and 3 to 6. I'll write this 6 and 2 to 6 also. You can join this. 2 can divide 6. And next is 4 to 8. So I'll write it here 4 to 8 and also we have 2 to 8. Just connect this. So this is your Hasse diagram. So for this relation, you can write the relational matrix. So for this matrix, I list all the matrix elements. So how many elements are there? 1, 2, 3, 4, 6 and 8. 1, 2, 3, 4, 6 and 8. So here you have 1 to 2. In place of 1 to 2, put 1 and 1 to 3 is 1, 2 to 4. 2 to 4 is 1 and the remainings are 0. 2 to 4 and 2 to 6 and 2 to 8. Remaining is 0. And next is 3 to 6 is 1. So remainings are 0. And 4 to 8. So 4 to 8 is 1. Remaining is 0. So this is 0, 0, 0, 0. So you can write this matrix representation for this Hasse diagram. Clear? So this is for 7 marks. Please practice this. Definitely there will be a problem on this Hasse diagram concept. Very simple concept. So in first unit, you will be studying this Hasse diagram also. And the next question is question number 14. 14th A. Show that P, V, P, V. V means what? It is a OR operation. It is logically mathematical logic concept. So here you have to prove that whether these two statements are logically equivalent or not by using truth table construction method. So how many variables are there? 3 variables, that is P, Q and R. So list the possibilities. So true, true and true, false. So true, true, true and true. First 4 is true and the next 4 is false and false. Next is for Q variable, true, true, false, false. True, true, false, false. And for R, true, false, true, false, true, false, true, false. Is it clear? Now, I'll find out this Q and R. You just use these two columns, Q column and R column. So here we have to use AND operation, that is multiplication operation. If any one of the condition is false, then the final condition also false in AND operation. So if it is both are true means we'll get true, otherwise it is false, false, false and false. This is Q and R. And next is you have to prove that P, V, Q. So P or Q. So P or Q means logical addition. So you just use these two columns P or Q. If any one of the statement is true means the final condition also true in OR operation. True, 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 false and false. Clear? False, false means false, false, false is false. And next is P or R. So logically addition for P and R. So here it is true, 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 true and it is false, true and it is false. And next is I'll find out this P or Q and R. So P and you just use this column P column and Q and R column. So here you have to use logically addition, that is logical OR operation. Use these two columns. So addition means true and true is true. If any one of the condition is true, it is true only. So it is false, false and false. And the next one is second one, P or Q and P or R. So here you have to use logically multiplication operation. So I'll use this P or Q and P or R column by using logical addition multiplication. So use this two columns, true, 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 and false, false, and false. Now you can cross verify that whether this statement and this statement is logically equivalent or not. You just take these two columns because this is the final columns I have found. So now true, 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 and 3 is false. So here also I got the same values. Is it right? So both are equivalent. So both the statements are equivalent. If you get the same statement for this statement, so here if you get for this two statement, if you get the same value, whether it is a true or false, if you get the same statement means it is A equivalent, otherwise it is not A equivalent. So by using this truth table construction, easily you can find out this concept. So definitely there will be a problem on this truth table construction. So easily you can score 4 marks. And next again you have truth table construction. So please practice this truth table construction. Easily you can score 8 marks in truth table construction. So now I'll find out this. So how many variables? Again we have P, Q and R. True, 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 true. False, false and false. True, true, false, false. True, true, false and false. True, false, true, false, true, false, true, false. Clear? Next I'll find out this negation R. So negation R is, so true means false. False is true, true, false, false, true, true, false, false, true, true, false, false, true. So this is negation R. Next I'll find out this Q and negation R. So here we have using, so here we have to use AND operation, logical multiplication. Take this column and this column. If any one of the statement is false in logical multiplication, the condition is false. So false, true, false, 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 true, false and false. And the next one is P or R. Find out this P and R, that is for logical addition. So if any one of the statement is true, then the final condition also true. Otherwise it is false. It is true, it is false. This is false. And the next one is, so here finally we have to find out this two columns. So Q and negation R implies P or R. So implication, so here we have to use a logical implication. So implies means you just take these two columns. So here first column and the second column, it is true, false, true is true, 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 true. And if in logical implication, if the first condition is true and the second condition is false means then only the final condition is false in implication. Already have discussed all the logical connectives in my previous session. So true, false is false. Otherwise all the conditions are true. So false, true is also true. False, false is also true. So this is your final conditions for a given problem. So here you have to use the logical connectives for addition and multiplication and implication. So this is about for 4 marks. Clear? And the next question is, so 14th C, prove that for all positive integers k and l, if k and l are both odd, then k plus 1 is even. So here we have to prove that if k and L are odd, then k plus 1 is even. So here we have to prove that k plus 1 is even. So here first step is solution. Assume that k and L are odd. So first I'll take k is equal to 2m plus 1. So already I have told you that k is equal to 2m plus 1 means, so if your integer value is even means it should be in a 2n form. If it is odd means should be in a 2n plus 1 or 2m plus 1, anything you can take. So even means should be divisible by 2, or odd means should be not divisible by 2. So k is equal to 2m plus 1 and I'll take L is equal to 2n plus 1. So now I'm going to prove this k plus 1 is even. So k plus L, I'll take this k plus L. So what is the value of k? K is equal to 2m plus 1 plus L value is 2n plus 1. So you can add these two values, 2m plus 2 plus 2n. Is it clear? So now rearrange this, 2m plus 2n plus 2. So I'll take 2 as a common factor. So m plus n plus 1. So now k plus L is in the form of 2 into n. Is it right? So it is a even. So therefore k plus L is even since it is divisible by 2. Clear? This is k plus L is even. So next you have to prove that k into L. So k and L are both odd, then k plus 1 is even. So already we got that k plus L is even. So I'll prove this k into L. So k into L means 2m plus 1 into 2n plus 1. So simplify this, 2 2s are 4 into m into n plus 2m plus 2n plus 1. So now I'll take 2 as a common factor, 2mn plus m plus n plus 1, remaining factor is 1. So only for this terms I have taken 2 is a common factor, 2 is a common, 2 into 2 is 4mn plus m and plus n and remaining plus 1 is there. So now this is in a form of 2 into n plus 1. Is it right? So 2n plus 1 means it is a odd integer. So k into L is a odd integer. So clear that? So here I have proved that for all positive integers k and L, if k and L are both odd, k and L means, so k and L are odd integer, then k plus 1 is even. Clear? This type of questions you can expect for 7 marks. Definitely there will be a problem on this concept. So this is indirect method in mathematical logic. So here you have to prove that k plus 1 is even, k into L is odd. So like that you can prove this by using this concept. Even means it should be in a form of 2n, odd means it should be in a form of 2n plus 1. So this is your 14th question C. So first part, and next you have 14th A, B, C again. You will be getting 2 questions. One question is choice for you. This is for today's session. In my next session, I'll explain the next questions. I'll continue the question paper. So now I'll stop the session because still you have to study some more questions in your model question paper. So this is for your today's session. So next important questions I'll explain in my next session. Until then, please practice these questions and get ready for your final examination. And next I'll come with the next questions, next question paper questions. So please prepare these questions well. In my next session, I'll discuss 14th, 15th and 16th questions. So this is for your today's session. So in my next session, I'll discuss the next question paper problems. Thank you.